Right, at the start of this next unit, we're going to be talking about polygons. And just today, we want to talk about basic polygons, their names, and then how to find the interior and exterior angles of those polygons. So to start with, what is a polygon? A polygon is a two-dimensional closed figure, meaning all of the ends connect to all of the other endpoints. Meaning like open would look like this, like that's an open figure versus that is a closed figure. Okay, so all of the endpoints connect is closed. It's not hugely important, but just if you see it, you want to know what the difference is. Made up of line segments, so no curves. So it would have to be, everything has to be straight. You can have any kind of polygon, it can look like that, but it cannot be like that. That's not a polygon. Okay, a convex polygon has interior angles that are less than 180 degrees. So this is a convex polygon. This is a concave polygon, and because it has this angle right in here that is greater than 180 degrees, or half of a circle. So convex is the important word that we are going to be using. And then a regular polygon, we'll be talking about convex regular polygons. Because in order to be able to find the interior angles and the exterior angles, we need to be able to know that all of the sides are going to be the same, equilateral, and all of the angles are going to be the same, equiangular. Okay, so that's what it means when it says a regular polygon. It means all the sides and all the angles are equal, and then when it's convex, it means it doesn't like cave in on itself. It looks like these. These are all convex polygons. Now, the word diagonal, we're going to use this word diagonal to develop where we're going next. So a diagonal is a segment that extends across the shape between two opposite vertices. Now you can draw any number, you can draw the diagonals from any vertex, it doesn't matter. But in this case, for this activity that we're about to do, I wanted to just draw in, we're just going to pick one vertex. So I draw in every diagonal that I could that would cut across the shape and would go to an opposite vertex. So this one is along the line, and so that doesn't count. So I can cut across, cut across. For this one, I started here. It doesn't matter which vertex you start at. I just picked one. And again, you won't be doing a lot of this, but this gives you the why behind in case you ever need to develop this idea again because you don't remember the rule. It's helpful to know where it came from. So these are the names of our polygons. Quadrilateral has 4 sides. A pentagon has 5 sides. A hexagon has 6. Heptagon has 7. Octagon has 8. Nonagon has 9. A decagon has 10. And a dodecagon has 12. Those are our main ones that we use. And then sometimes it might refer to an n-gon. Say maybe, for instance, a 23-gon. If I ever say a 23-gon, then a 23-gon has 23 sides. So the n-gon has that many sides. Sometimes we'll refer to those because we want to use bigger than 12 sides. And they don't get special names. They just get called by the number of sides. So you do need to know these. So if you don't know them and you don't know these sides, you might need to pause the video so that you can take a second and get this copied down. Now if I go back to my quadrilateral, here's my quadrilateral right here. It has 4 sides. And I draw in my diagonal. I notice that I have 1 triangle, 2 triangles. And so when there are 4 sides, there are 2 triangles. When there are 5 sides, like this pentagon, I have 1, 2, 3 triangles formed by 1 set of diagonals drawn from 1 vertex. So there are 3. So when there were 4 sides, there were 2 triangles. When there are 5 sides, there are 3 triangles. When there are 6 sides, I have 1, 2, 3, 4 triangles. Now, hopefully you're starting to notice the pattern. 4 minus 2 is 2. 5 minus 2 is 3. 6 minus 2 is 4. So what you should notice is that there are 2 fewer triangles for the number of sides. There are 9 sides, there are 7 triangles. If there are 10 sides, there are 8 triangles. So if there are n sides, then there are n minus 2 number of triangles. Now the reason that we need to know that is because ultimately my goal is to find the sum of the interior angles of all polygons. So I'm just starting with the ones that I know that are easy for me to draw. So this is where it comes down to it, right? Because we know that the angles of a triangle equal 180. Every triangle is 180 degrees. What that means is these three angles right here add up to 180 degrees. These three angles here add up to 180 degrees. And these three angles here add up to 180 degrees. And then what you need to notice is that all of those angles together, so those three added together, this one, these two added together, these two added together, and this one all create the interior angles, the ones that are inside that pentagon. So it creates those interior angles. And so I can tell what they all add up to by taking the number of triangles and multiplying it by 180. So in the end, okay, we have our polygon interior angle sum. Interior sum. Okay, we're going to do an interior sum, and then we're going to do each interior. We're going to do an exterior sum, and then we're going to do each exterior. So it's important to recognize the difference between what you're being asked for. So the sum of the interior angle measures is the number of triangles, n minus 2, times 180, because every triangle adds up to 180. So this is the number of triangles, and we multiply it by 180 because each of those triangles has 180 degrees. So this is what the question might look like. Find the sum of the interior angles of a 15-gon. A 15-gon has 15 sides. If it has 15 sides, then it has 15 minus 2 triangles. Each of those triangles has 180 degrees. So I would take 15 minus 2 times 180, or 13 times 180, and I would find out that the sum of the interior angles is 2,340 degrees. Okay, so the sum of the interior angles, all of the angles on the inside of a 15-gon, will add up to 2,340. Because notice, as you increase the number of sides, do you see how those interior angles get bigger and bigger and bigger and bigger, right? They get more and more they get closer to 180 degrees is what happens. So they become it starts to become looking more like a circle. So find the sum of the interior angles of a 15-gon. You would find the number of triangles, multiply by 180, and that gives you your sum. Now, what if I want to know how much each one is? Now, it's a regular pentagon, which means all the sides are the same and all of the angles are the same, and that's important. We can't do this unless it is a regular polygon. So I want to know how much each is. Well, in order to know how much each of it is, I have to know how much all of it is first. So the first thing I have to find is I have to find the sum. Well, the sum is the number of triangles. A pentagon has 5 sides, right? A pentagon has 5 sides. So a pentagon has 5 sides minus 2, that's the number of triangles. That's 3 triangles times 180. So you don't have to memorize this table. The point of the table was to show you where everything came from. You don't have to memorize it. This is the only part you need to know. So 3 times 180 is 540. So all of the angles on the inside of a pentagon are 540. But I want to know what each one is. If they're all the same, then how much is each? Think about it. If I take $500 and I say that I'm going to give you each the same amount, I would take $500 and I would divide it by the number of students in the room. That would tell me how much each of you is going to get. So if I have 540 degrees to hand out, I'm going to divide that by 5 because there's a pentagon and pentagons have 5 sides. So I have 5 degrees total, 540 degrees total. I have 5 sides in all, and 540 divided by 5 is 108 degrees. So each of those angles, if I were to draw it, if I could draw it really well, each of those angles would be 108 because it says that it's regular. So each of those is 108, which adds up to 540. Okay? Now, let's talk about exterior angles. Those are interior angles. So 61, 40, and 79, those are interior angles. So let's look we know the sum of these interior angles, they should be 180 because that's a triangle. But I'm talking about exterior angles now, and these are my exterior angles. There is one exterior angle at a time. You have two options, but we're only going to use one at a time. So we have one angle, okay, one. Now notice the interior and the exterior equal 180, okay? Interior plus exterior equals 180. They form a linear pair, okay? Interior and exterior form a linear pair. So if that's 40, then this exterior angle is 140. If that is 79, then this exterior angle is 101. If this is 61, then this exterior angle is 119. Now, what I want you to see is this. Let's add up 119 plus 101 plus 140. When you add those together, you get 360. So the sum of the exterior angles of a triangle is 360. Now let's do the same thing here with this 1, 2, 3, 4, 5, 6 hexagon. This is a hexagon. So we're going to take each one and find that exterior angle. These are all interior angles. They are inside the shape. So if I find this linear pair, this is 65. And go around and find each one. This linear pair is 51, 56, 68, 57, and 63. Those are all my exterior angles. I get one exterior angle at each vertex. Okay, these are all add up to 180. So now let's try this. Let's do 65 plus 63 plus 57 plus 68 plus 56 plus 51. And guess what you get? Notice they're smaller. So when the insides get bigger, the outsides get smaller. Notice these angles are smaller than the triangle angles. The exterior angles are. Okay, and so, but notice this. All of those add to 360 degrees. So the question is then, what do you think? What do you think the exterior angles, if the sum of a triangle add up to 360, the sum of a hexagon angles, the sum of the exterior angles of a hexagon add up to 360, what do you think the sum of the exterior angles of a dodecagon, a 12-sided figure, are? If you answered 360, you are right. It does not matter how big it is or how small it is. If you have the exterior sum, will always add up to 360. The exterior angle sum will always add up to 360. Here's the cool reason why. If I were to take this shape and cut it up and cut out each of these angles, if I were to cut out each of these orange pieces like this and put them together vertex to vertex, it would look something like this. If I put them all point to point and put them all together, notice they would make a circle. Same thing here. If I were to put these together, they would look something like this. Obviously, it's not drawn to scale, but it would look something like that. They would form a circle, and we know that the angles of a circle are 360 degrees. Okay, that's why those exterior points do that. The interior angles don't do that. So now you have to, that's something you have to memorize. Okay, know that. Find the sum of the measures of the exterior. So you have to pay attention. Do I want the sum of the interior or the sum of the exterior? So I want the sum of the exterior angles of a 24gon. Now, it doesn't matter how big it is. A 24gon has 24 sides, but it doesn't matter. It has 360 degrees exterior. The sum of the exterior is 360 degrees. Now, what about each exterior? Each exterior, I've got 360 degrees to share. 360 degrees to share between those 24 sides or 24 angles. So 360 divided by 24 angles gives you that they are 15 degrees apiece. So if I have a shape that has 24 sides and 24 angles, then each of those exterior angles will be 15 degrees. Now, think about this then. You could find each interior angle based off of that, because you know interior and exterior add up to 180. So I could, if I wanted to, I could now go into and find the interior angle from there. Okay, if the exterior angle of a regular polygon, we're going to use that idea right here. If the exterior of angle of a regular polygon measures 12 degrees, how many sides does the polygon have? Well, the exterior, all of the exterior angles always has to add up to 360 degrees divided by the 12 degrees that I have. So I'm going to take a full circle and I'm going to break it into 12-degree pieces. Then what I have is 360 divided by 12. I have 30 sides. So I have 360 degrees exterior to share. If I'm going to break them up in 12-degree increments, that will give me 30 sides. If I have 360 degrees to share and I have 24 sides, then that would give me 15 degrees. Okay? So let's look at these and get a little bit of practice. So what is the sum of the interior and exterior angles of a convex decagon? A decagon, again, has 10 sides. The fact that it's convex just means that it doesn't cave in on itself. So it's not important to how we do the problem, except that it has to exist to be able to do the problem. So what is the sum? The sum depends on how many triangles we have for the interior. So the sum of the interior, if there are 10 sides, then there are 10 minus 2 triangles. So there are 8 triangles. Each of those triangles has 180 degrees. So 8 times 180 is 1,440. Okay, so all of the angles inside a decagon are 1,440 degrees. The sum of the exterior never changes. Exterior is always 360 degrees. And as easy as that is, that's going to be hard for you to remember. You got to commit that to memory. Okay, the next question says, find the measure of each one exterior, interior, and each exterior angle of a regular octagon. Well, in order to find each, you have to know all, right? In order for me to know how much money I'm going to give each of you or how many pieces of pizza I'm going to give each of you, I have to know how much money or how many pieces of pizza I have in all. So in order to find each, you have to find all first, okay? So all, I have 8 sides, which means I have 6 triangles, right? N minus 2, 8 minus 2. So 6 times 180. I have 1,080 degrees to evenly distribute between those 8 angles. Each one then would be 1,080 divided by 8 because there are 8 angles. Each interior angle is 135 degrees. Now there are 2 ways that you can find the exterior. You can do 180 minus 135 and get 45. You can get it that way, or you can stay with this concept of all. You can say they all add up to be 360, because it always does, divided by 8. And if you do 360 divided by 8, you still get 45. So you can do interior plus exterior equals 180, or you can use all. You can go back and say, well, all of them add up to 360. So if there are 8, then each of them is going to be 45 degrees. Those are your options. Okay? And then these last 2 problems. In order to be able to find out how big each one is, we've done this before, right? We have always done, like, what's the missing angle? So in the past, we did triangles that looked like this. This was 60, this was 40. How big was this missing angle? And you said, well, the angles of a triangle add up to 180. So I would take 60 plus 40 is 100. I would subtract that from 180 and find out that that missing angle had to be 80. We're doing the exact same thing, only we don't know off the top of our head what a 1, 2, 3, 4, 5, 6, 7-sided figure adds up to be. Well, a 7-sided figure has 5 triangles. If you don't remember that, you can always draw in those diagonals and figure it out. So 5 triangles at 180 degrees apiece is 900 degrees. So I have 900 degrees to use up in this triangle. I have used up 90 plus 165 plus 125 plus 95 plus 155 plus 150. We need to make sure we use all of our angles. I have used up 780 degrees. Okay, so Z plus 780 degrees is equal to 900 degrees. You don't have to write it down as an algebra problem like this, but I want you to see how it works. Subtract 780 from both sides, and you get that angle Z is 120 degrees. That angle right there, if it's 120 degrees, they will all add up to 900. And we can use that same idea when we're dealing with algebra. This shape has 1, 2, 3, 4, 5 sides. So what are they supposed to add up to be? Well, if you don't remember, there's 180 for that triangle, 180 for that triangle, and 180 for that triangle. There are 3 triangles at 180 apiece. N minus 2 times 180. Number of sides minus 2 times 180. That means that there are 540 degrees that I can use. Now I can write this all down, but I'm going to save us a step here. I'm going to go ahead and combine all my like terms, because what I want to do is 5x plus 2 plus 3x plus 5 plus 8x plus 8 plus 4x plus 15 plus 5x plus 10. But I don't want to have to write all that down and set it equal to 540. What I want to do is I'm going to go ahead and combine my like terms. 5x plus 3x is 8x, plus 8x is 16x, plus 4x is 20x, plus 5 is 25x. So I have 25x, then I have 2 plus 5 plus 8 plus 15 plus 10. Okay, 2 plus 5 plus 8 plus 15 plus 10 is 40. So 25x plus 40 is equal to the total angle of 540 degrees. From there, solve the algebra. Subtract 40 from both sides. 25x is equal to 500. So 500 divided by 25 says that x is 20. Now, I only wanted to find x. That's all I asked for. So since all I asked for was x, then I can stop there. If I had asked you for angle B or angle C or angle D or anything like that, then I would substitute it back in. For instance, angle D would be 4 times 20 plus 15. Okay, so you can use it to go back in and find that. Okay, so you can find, so in summary, I can find the sum of the interior angles of a polygon by, you either need to memorize the rule n minus 2 times 180, or you need to be able to find the number of triangles by drawing in the number of diagonals, counting the triangles, and multiplying them by 180. And then the exterior angles always add up to 360.